All right, guys, I think it's time to get started. We have a really packed session today, so thank you all for attending. Really quickly, how many of you guys were here yesterday? Well, not in this room, but for the intro session?
Good.
Good.
Thanks for coming back.
Yeah, thank you. Appreciate that. So, Patrick, you want to introduce yourself?
Yeah. So I'm Patrick Lang. I'm a developer over at Microsoft, and I'm working on Kubernetes on Windows and on Azure.
Cool. I'm Michael. Me and Patrick are the chairs of SIG-Windows, and I work at VMware.
All right. So we got a nice long list of topics, and we're going to have to move pretty quick to get through all of this. So we're going to start off talking about a couple of the best practices and deployments, so that way you know a couple of the things you need to plan for as you start to add Windows nodes into your clusters. And we'll talk a little bit about how to handle node maintenance, how to get more detailed application logs out of your Windows apps that are running in containers. We've got some new developments there that we're excited to share. And then sort of talk about what some of the next steps are from that point in terms of getting the tooling together to be able to do things like centralized logs, better monitor your nodes, and really kind of round out the operational solutions that you need. That's an area of active that we're looking for new contributors to help out with in SIG-Windows, because there's a lot of solutions that are in the works but not quite over past the finish line yet. And then we'll finish with a little bit on disaster recovery. So jumping straight into some of the things we need to talk about when you're running multiple operating systems in a Kubernetes cluster. So Kubernetes already has a concept of something called a node selector. And what it does is it lets you match deployments to a specific node based on a set of labels. There's already a label that's there that's kubernetes.io/os, where your typical values that you're going to see are Linux or Windows. Those are automatically added to all the nodes. And that's really important because you need to make sure that you're steering your Windows workload onto a Windows node and Linux one onto a Linux node. And for 1.17, what's really important is we're also adding a new field that's automatic so that Windows nodes will automatically label themselves with the version that they're running. You could still do this on older versions, but you'll just need to go do a manual step with kube control, was a label node, and then set this up so you can put it on there. But using the combination of these two things, now if you want to run multiple Windows versions in the same cluster, you've got a way to do that and match them with a node selector. And so if you're doing all this just on a per deployment basis, you're going to end up with around 8 lines of YAML here. So that way you can basically set the right node selector and then also set a toleration if you're using taints to make sure that if someone doesn't label an application, it defaults to Linux. And so that's, when you're adding Windows nodes into a new cluster, that's something that we've generally seen to be a good best practice, is to taint the Windows nodes. So that way, if you've already got something deployed, and let's say you haven't updated your Helm charts or whatever, it's not going to accidentally end up on a Windows node where it's not going to start. And so you can basically taint the nodes before you add them to a cluster to steer things away. But then you add a toleration on the specific deployment, and now it can be deployed there again. And so this is what it would look like if you were to do this on each individual deployment. But there's a great feature in Kubernetes called runtime classes that in version 16 started supporting actually adding these automatically at scheduling time. And so what you can do is you can define a runtime class once for the cluster. You can give it a name like Windows 2019, and then you could take all those scheduling constraints that you wanted to put in there and encapsulate those all into one part. So when you go to actually update your deployment, all you're doing is adding one line that says runtime class name Windows 2019. And so in this case, if I wanted to go and deploy a newer version of Windows side by side, I could add a second runtime class, and I'm just telling my developers to add one line to their deployment, and then their workload will get steered to whichever version of Windows they're doing. And so this is something that's in a doc PR for 1.17, and we're recommending that as a way to go forward and make it easier to smoothly run multiple versions in the same cluster. So that's something to look at from a scheduling standpoint. One of the next questions that we commonly get when people are starting out are, well, what do I need to do when it comes to resource consumption? And so the two main areas that you need to look at things are when you're creating your container spec on there and you're adding your resources, you can put CPU and memory on there. So the initial implementation of CPU, when we started on Windows Server 2016, didn't have CPU percentage implemented, but it did have shares implemented. And so what that meant was, on a fully loaded system, the amount of time given to each container was proportional, but it didn't mean that you could set a particular cap on a container. It could always burst past whatever that threshold is. And so there's actually a PR open that we'll be reviewing next week to get this updated, because in newer versions of Windows, you can do one or the other. And so we'll be updating our guidance soon on how you could pick between those two scheduling modes and do the absolute cap scheduling based on CPU percentages. And so the next step is memory. So starting Windows Server Core generally needs about 200 megs allocated to the container. It may not necessarily use all of that all at once, but because you're bringing up all those background services, you need to have that room for them to expand in order for it to be functional. And so we'd recommend that you use that as a minimum when you're deploying containers with Server Core. If you try to do less than that, you can get to a state where it'll look like a container is starting, and then in the end it just fails and gets into a crash retry loop. And so you'd want to avoid that. Did you want to talk about that?
Yeah. So that was some of the memory considerations for the actual container. But the host itself also has additional memory considerations. So when you kind of look at the host today in Kubernetes for Windows, you may be running ancillary processes, whether that's backup, monitoring, other services that your organization needs, plus all the containers. Today in Windows, there's no pod eviction. So if a certain container ends up taking more memory than it was originally allocated or what you were expecting for it to use, what's going to happen is we're going to start paging to disk. So your container now is going to run slower. On top of that, it's going to start eating resources out of the host OS. So our recommendation is to basically, until we get pod evictions and the ability for us to enforce a memory allocation on a container in Kubernetes and in Windows, is to use kubelet reserve as well as the systems reserve to keep at least 2 gigabytes. That's the really bare minimum for the node processes. And what's going to happen there is Kubernetes and the scheduler is going to help enforce that, along with the ability, when you add limits and reserves on your actual containers, the combination of those plus the node allocatable will help the scheduler decide which containers they can put on each node.
All right. So a lot of the topics we just talked about are all things that are specific to the Kubernetes deployment, and it's a place where people can make mistakes. And so one of the things that we can do, because this is part of the same Kubernetes ecosystem, is if you look at tools like Open Policy Agent, which when you want to implement it on Kubernetes is typically done through Gatekeeper, they provide an admission controller, and then Open Policy Agent has a language that you can use to basically look at the YAML before it gets deployed. And so if you wanted to start developing best practices for your organization and taking some of the things that we just talked about, like making node selectors mandatory, checking the minimum memory, and making sure that limits are applied on memory as well so that you're not over-provisioning nodes, you could encode all of that in a language called Rego, and then Gatekeeper would actually be able to block deployments that don't meet that spec. If you're not ready to go into a blocking mode, there's also a tool called ConfTest, And I think there was a presentation on this at KubeCon. If not, there was definitely one at Barcelona earlier this year that you could look at. But it uses the same open policy agent engine, but it's something that you can run on your developer laptop before you do a deployment. So when you go and create your YAML file to deploy everything, you could just run the same set of rules against it, and it will tell you if there's any violations. And so that gives you a great way where you could basically start developing the rules and testing them on some of your existing deployments before you go and make them blocking with Gatekeeper on the admission side. And so that's an area that we'd love people to help us sort of start developing those best practices. And one of the goals of Gatekeeper is they want to have a library of pre-made best practice policies there in their repo. And so they want to start collecting that stuff. And so that would be a great place where someone could jump in and start saying, okay, here's mistakes we've seen. Let's try to automate those out of existence.
And by the way, on the OPA stuff, we can actually use the SIG-Windows tools repo to kind of help capture the community contributions in that area. So now you basically had some of your Windows nodes up and running for a while, and it's time to patch them. Microsoft publishes updates on a very regular cadence and in a very predictable manner. So there's a couple of ways that you can actually follow to patch your Windows nodes. Let's start with the one that might be considered the easiest. So if you have workloads running on that node and it's a production node, then the first thing you need to do is you have to cordon the node in Kubernetes. So what that means is that node will not get any new containers on it, so nothing new will be scheduled on it. Then you have to wait, because studies have shown that a lot of the containers are fairly short-lived. That may not be as applicable on the Windows side, but it is more true on Linux. So you have an option to wait for a small period of time, and if your containers don't basically finish what they're doing and exit, then you have to drain the node. And then you run your Windows update, reboot the node, update drivers, or anything else that's necessary, and then you uncordon the node, and then immediately it's going to be part of the scheduler, and new containers will land on it. Now, if you're swapping a node, that means you're replacing the entire node with something new. Again, process is very similar. You cordon the node, you wait, drain all the existing applications. Now, if you drain an existing application that has in-flight requests, they're going to basically, the user of that application, whether that's another app itself or an end user, they're basically going to get a canceled transaction or a 404. And you get to replace them a node, very likely rejoin the node to the cluster if it's a replacement, and then you get to uncordon it and basically get it to be part of the scheduler. Now, there's a few things to think about. If you are doing these updates, you need to have enough capacity to service the existing workloads that you have in your cluster. And you have to think about how long it takes for you to deploy. And if you are in a public cloud provider, it's very likely that adding a new node or doing a full swap may be faster than doing a patch and upgrading in place. So think about all those things. And obviously, anytime you update the Windows operating system, it's good to do some testing of your applications on that, whether that's canary deployments, A/B testing, blue-green. Figure out what works for your environment, but validate that the applications that you have running in those nodes will really work with the new upgrade of the operating system. Now, outside of updates, there's also upgrades where you're doing a major OS upgrade. Again, the process is very similar. You cordon, you wait, you drain, and then you upgrade. But there's a caveat here. You cannot in-place upgrade from a long-term servicing channel. This is the releases of Windows that are serviced over a long period of time and supported over a long period of time by Microsoft to a semi-annual channel that's basically released every 6 months. So that's something to think about. If you are going to go from one to the other, make sure that you build out new nodes. And be careful, so as you're doing all of those processes, that your node selectors are set correctly, the tolerations are set correctly. So one of the things that Patrick mentioned earlier is this new label that you have that indicates the major OS version. If you're here yesterday, one of the things we talked about is that in Windows, the major OS version of the guest OS and the major OS version of the host OS needs to match. So as you're upgrading the OS, make sure that that matching actually exists both at the application level, which is your Windows container, as well as at the container host. And make sure you taint your nodes appropriately for that. Now, Hyper-V isolation is going to make some of these things easier because it will allow you to run a container with a different major OS version than the container host. So step number 3 there, where you're rebuilding your application, is going to be significantly simplified. Now, one of the things that we're also working on is Cluster API that will offer a declarative Kubernetes-style way to provision clusters. Everything from node management to cluster management is going to fall into Cluster API. Although Windows is not there yet, well, Cluster API is also not there yet, so we're in lockstep there. We are actually going to make this one of our priorities in 2020 to make sure that Windows nodes are a part not only of the specification, but a part of the implementation at the different cloud providers, Azure, AWS, GCP, as well as vSphere.
Okay. So we briefly mentioned that we have the 2 servicing channels. There's the long-term servicing channel and the semi-annual channel with the different support segments. And so Microsoft has a chart that's available that basically shows like what the build numbers are for each one of these, when it was made available, and when it's going to end support. And so one of the things that we want to gather some feedback on, is actually getting a little bit more details. What we're looking for is we'd like some feedback from you on whether or not this upgrade cycle works. Because one of the things that we want to make sure that we're doing in the SIG is come up with a plan to test and support the certain releases in a way that aligns both with the duration that the Windows Server release is going to be available, but also across multiple Kubernetes releases. And so if you can grab that address.
If you guys can grab your phones out and see if you can visit the address really quickly. It's bit.ly 347 MOUI.
I'm sure there's a way to keep that on there. Next slide. And so we actually have a couple questions here.
Did everybody get the address? So.
Does the address at the top still work?
There's people already starting to.
Okay.
So you're going to see some questions there.
Yeah. So in order to use the semi-annual channel, you have to make sure that you've got a license for it. And this is something that is licensed 2 ways. If you're an on-prem customer, you can get it as part of your Microsoft software assurance options. And it's also provided to service providers so that you can run it on your choice of, AWS, Azure, Google, and other clouds can license this as well on your behalf. But the important thing is that it's not something that's sold in like a retail box the same way that the long-term servicing releases are. And so that's kind of like one of the first questions is like, are you in a position where you can actually deploy this in your org or consume it from your cloud provider? And so wait just a second.
We've got some answers here, so I'm going to go ahead and lock this so we can get our results.
Okay. Yep. Okay.
Could even blend. So I'll go to the next question.
Okay, yep. So it looks like a pretty even split. And so the next thing is that when you're on the semi-annual channel, those releases come out every 6 months, and they're going to be supported for 18 months with updates from Microsoft. And so the question is that means that when you get on that channel, you've got to remember, you've got to be in a position to do that upgrade at least every 18 months. And so is that something that sort of makes sense to you, or is this something where, or is that basically a release duration that is faster than you could deploy in your environment? So, well, it looks a pretty even split. Looks like we need to get more information on what the improvements are before we could really decide for there.
Yep.
So, all right, let's just keep going on. All right. It says it's full? Wow, okay, that's an accomplishment. Thanks everybody for coming. We overloaded the system.
Interesting. All right, so let's talk a little bit about the anatomy of a container. By the way, on the questions that we asked you earlier, if you have additional feedback and you want to get a little bit more context, you can find us on Slack under SIG-Windows in the Kubernetes Slack. You can ask your questions there. So looking at the anatomy of a Windows container, the way we view it is, obviously in certain organizations this might look a little bit different, but at the high level, you start with a base OS image that Microsoft provides. Microsoft is the only one that's allowed to basically distribute and create the base OS image for different Windows SKUs. Then you have your runtime layer, and that could be, if you're running .NET, then that's .NET, or it could be .NET Core, it could be Python, Node.js, or anything else that you're running your application in, any service brokerage, and then the application component. The goal here is that you should always try to use derived images so you can share your building blocks. So Microsoft publishes a wide variety of derived images from ASP.NET to IIS-based images to even Python. So make sure you leverage that because they've done a great job of basically building the OS and wiring the necessary components for your applications to work. And if you actually utilize that, then that means that you're getting that consistency across every time you build your images. So,
yeah. So when it comes to actually patching your images, what you want to make sure that you're doing is starting from one of the official Microsoft images. And so if you go to Docker Hub to browse what's available, if you go and look at Windows Server Core or Nano Server, we've got a whole bunch of different tagged images, and these are basically updated on a monthly basis. And so within the tags, you could basically see what the major OS version is, as well as what the patch level is on it. And then they have the version numbers for reference, and they show when it was published and updated. So one thing I want to call out here is there is no latest. Let me repeat that. There is no image called latest for Windows Server Core. And the reason for that is because we've got 3 different major OS versions that are there, and we need to make sure that you're picking the specific one that is going to match what you're going to run in production. Because if you were to go in there and choose one that was like 1903 and try to run it on Windows Server 1809, it's not going to start. And so what you want to do, if you're in the case of like 1809, is look for the new tag that basically matches that month's patch Tuesday. And so the most recent one is down there at the bottom. And you can basically see it was released on the 12th, and the KB numbers behind that nice little bar there from presentations. But what you can do is that becomes one of the first lines in your Docker file. So like the Windows Server Core and Nano Server images are patched by Microsoft and released, and so you can just build on top of them and build up from there. The derived images like ASP.NET Core and the Internet Information Server are also updated following the same scheme. And so what you'll want to do is basically go update the from line in your Docker container, rebuild it. Hopefully you've got a continuous integration delivery system, and then deploy it. And so rather than going and trying to like graft a patch into a container, you want to just follow the same process you do for all your releases and just update the from line and rebuild and go from there. And so I've seen this implemented in lots and lots of different tools. I basically started alphabetically and realized that I was going to run out of space. But just looking at different projects that we've got, like within the Kubernetes repos and some of the other ones, I've seen everything from AppFair to Azure DevOps to container registries that update stuff. People have done demos on Circle CI, CodeFresh, Docker Enterprise, and there's basically too many to list here. But the key thing is take whatever you're using to do your builds and deployments and make sure that you make this part of a regular thing, because you don't just deploy once. You're going to be deploying monthly to get those patches rolled out.
So if there was a limitation where you said the container OS has to match node OS, right?
Yes.
So if you're doing those 6 to 18 month cycles, then you're doing all of that at the same time?
Yeah. So I'll restate the question for the recording. So the question was, if you're following the semi-annual channel releases on the 6 to 18 month deployment cycle, then yes, you also have to go and update all the containers that are going to be running on that, and then deploy them. So that way you've got matching major OS versions between the node and the container. You can have multiple Windows versions running within the same cluster, but that means you're going to have basically different nodes running for each one of those OSs.
You're reducing your availability though in that case, right?
Yeah.
So if you have like 3 nodes, one with a different host OS, then that means the containers can only land there. So your options for high availability are significantly reduced. One of the things that's very important here to note is if we actually go back to this diagram, I can very efficiently and with a high degree of confidence change that first line to a different patch of Windows. And I'm confident that a lot of the rest of the steps are going to work the same. Windows is backwards compatible at the API layer, at the .NET layer. So if you're starting always from the source of truth, which is here's the base image provided by Microsoft, and then you wire in your application code and your application components, if you do it in a declarative way like this, it's very likely it's going to work across many patches of the OS as well as upgrades. Obviously, you have to test it, but there's a high degree of confidence that this will work. And I mean, this example here is Blog Engine, and I know for a fact it will work across a couple of different OS SKUs.
Yeah. Okay. So moving on to the next topic, one of the pieces of feedback that we've heard is that since Windows has a lot of background services that are running, like the Internet Information Server, those basically log the binary logs that Windows calls the event log or event tracing for Windows. And most of the tools in the container ecosystem that started on Linux were based around parsing standard out for logs. And so 2 weeks ago at Microsoft Ignite, there's actually an open source tool released called Log Monitor that's able to basically collect, you can basically build up a list of what logs you care about for that container, whether it's event tracing for Windows, event logs, or custom app logs like your http.log from IIS, and it can basically stream all of these to the standard output for you. So that way, if you're going to go and deploy something like FluentBit and Elasticsearch to basically collect all those logs for you, you now have a way that you can put something in your container that will extract all that information where those tools can grab it. And I've got a demo of this coming up. So this is released on GitHub, so the URL's there in the slides. And let me show you how this actually works. So I took an existing application that I already had that did not have sufficient logging. Like before I did this, if I wanted to see the logs for this container, I had to do a kubectl exec, go in there, cd over to the directory containing my logs, and then use get content or tail to try to analyze those. And it was a very kind of a intensive process that wasn't very friendly. And so the changes I made were basically downloading this log monitor release, and then I added in a config file, and then the last thing I did was I set my shell so that way anything I do from this point on would be captured by log monitor, and that configuration would basically be applied. And then the last thing I'm doing is basically making sure that I'm still starting my application with the same entry point I had before. And so, log monitor is basically handing this down the stack, but still capturing all the output as it goes. And so the JSON file that I passed in there basically is setting up a couple different event channels. These ones are based on Windows event logs. And so like if you log into a Windows 10 machine and you go to event logs and you see like system and application, that's where people typically go to look for like failed services and crashes. I can collect both of those. Moving on to files, since I'm running under IIS, I want to get my HTTP logs so I can actually see what the result codes were and what the URLs that people were hitting. And so I've basically told it capture all the logs from that directory for IIS. And then the last thing is, because IIS has some more detailed logging that's done in event tracing for Windows, which is a structured data format, I've also asked Log Monitor to go ahead and capture those based on the GUID and name that's there and format those into text for me. And so that means within one log, I can see everything from crashes to the addresses that the users are hitting for the site to some internal diagnostics for the IIS service itself. And so let me get this playing there up to full screen. And so this is a demo that I set up for KubeCon last year, and I rebuilt it with Log Monitor in there. And so what I did was, since I had a new image there, I just went and updated my values on my Helm chart to actually go and do a deployment. And so after that, and this is actually using Helm 3. I didn't change my Helm chart. It just worked going from Helm 2 to Helm 3, so thank you, Helm team. And so after that deployed, we see that the service is still pending, and then the pods are on their way up. So give us a few more seconds here. And now at this point, I'm just waiting for the external IP to be there so I can actually go and reach the site. And then, so while I'm waiting on the load balancer to actually come up and finish provisioning that external IP, I can already go use kubectl logs to look at what's been logged in that container. And so it's really important here, actually, step back just a tiny bit so we can actually read that, is we could actually see all the background services that were starting up on Windows, and the last line shows that the World Wide Web Publishing Service actually entered the running state. So let this keep running, and the next thing we're going to do is actually go and access this. And so at this point, the service is up, I've got an external IP, and so we'll go access that in the web browser. And this site's actually still up right now if you want to hit it. But looking at the logs again, the same kubectl -f works for follow. So if you're basically watching a deployment as it happens, you can use that same process there. And so now, since I hadn't warmed up that site, it's basically warming up all of its caches, and it's actually creating the outgoing database connection to where it's going to store its stuff. This code's unchanged from the last time I demoed it, except for I just dropped that log monitor in there. And so now that the site is up, and we'll do a little bit of activity on it. And then let me just jump forward just a little bit here just to save a few more seconds. And then going back to the log down here, we can see that it started streaming in all the events from the HTTP log as well. So now at this point, since the HTTP log is a very well-known format, I can use existing tools to go ahead and monitor how that pod is actually going and start looking for problems as this stuff is running. So that's kind of, the first step there is providing an easy way to get logs out of the container in a way that's consistent with what other frameworks are doing. And so the next step from there is now this enables some tools like FluentBit seems to be the one that that's getting the most attention right now in this topic, but it can go and basically grovel through those logs from all these nodes, either through the Kubernetes API or by looking at them on disk, because the kubelet always writes them out to disk. And that gives you a way to aggregate all of those into one place. So that way you could look at them, with like Elasticsearch and Kibana, or if you've got a provider-specific solution like Azure Monitoring, those can all pull from the same data. Why isn't that working? Okay, so right now there's a track. So FluentBit has been available as a beta on Windows since version 1.1, and then there's actually a master issue that's sort of tracking that progress that's there. And so this is something that people are actively working on, and I'm sure there's room for more people to jump in and start experimenting with it as well. I know that Ben, one of the folks from SIG-Windows, has started looking at this as well. But what we're looking for is, like what tools do you need, and are there people that can help sort of continue extending this ecosystem that started in Linux to work with the operational needs on Windows containers as well. And so going past specific log events from containers, there's also the need to be able to monitor your node metrics. So Prometheus has already been ported to Windows for some time, and it has a scraper that can basically go and get things from the Kubernetes API. So it can find pods and like the memory usage and things like that that are being used. But if you want to correlate that to what the overall usage is on a node, there's a WMI exporter that's open source and available, and that's what can provide the node level metrics that you would get instead of using the node exporter, which is Linux specific. You could use the WMI exporter on Windows and configure that to expose CPU, memory, disk, network, and other typical things that you need if you want to look at how your nodes are running in production. Okay.
All right, and I realize we're actually out of time, so I'll go very quickly. So on a compliance standpoint, make sure that you bake compliance into your CI/CD process. So host your images in a private registry, whether that's something like Harbor on-prem or any of the registries in public cloud providers where you have your own private account. And then you can use tools and technologies like Agua Security and Twistlog to go in and either scan your images from Harbor or scan your images in any of the public cloud providers for vulnerabilities. If you want to, you can also use the OPA capabilities that Patrick mentioned earlier to do some enforcement as well. So look at this from a holistic viewpoint. Enforce compliance at the CI/CD layer, at the code layer, and then go back and make sure that whatever gets deployed to Kubernetes is really secure and doesn't have any issues and critical vulnerabilities. On the disaster recovery front, start using some of the same principles that you're using for your containers today on Linux. That means backing up your Kubernetes state, backing up your persistent volumes. You can use Velero for a lot of those capabilities. And then start thinking about, if you were to do a multi-cloud DR, how would you do that with HA? Some of the same principles that apply on Linux also apply on Windows, but then you always have to think about the trade-off between availability and consistency. That's the CAP theorem. So always have that in mind. We're also working with the Velero team to make sure that we have fully supported Windows backups for your Windows applications on Kubernetes. So that's something that's going to come up soon. How you can help? Come to our SIG. You can help with improving documentation, writing some blogs, fixing bugs, attending our meetings, and just sharing your story. Where to find us? We'll publish this slide deck as well, but you can find us on Slack, on Google Groups, find us on GitHub, or attend any of our meetings. Since we're out of time, we won't take questions now, but we'll be here on the side, so you guys can come and ask us anything you want. Thank you.
Yeah, thank you.